Good day everyone! Welcome back to another video of CHE 101. And in this video, we will talk about limits. Now let us start with the definition of a limit. So a limit is best described using the equation shown on the screen. So we read this as the limit of f as x approaches a is equal to L. By definition, let f of x be a function of an open interval containing a except on the number a itself, and where L is a real number. So here, when we say that x approaches a, we do not consider that x is exactly equal to a. The thing that matters here is how the function is defined near a. Next, let's go through the theorems of limits. For theorem 1 and 2, when the limit of the sum or difference of two functions is asked, the limit can be separated into the two functions, and that is equal to the sum or difference of those limits. Theorem number 3, when a constant, as defined by C, is multiplied by a function, that constant can be separated outside of the limit. 4. The limit of the product of two functions is equal to the product of their separate limits. Next, the same goes for division of two functions. However, it is to be noted that g of x must not be equal to 0. This is to ensure that the answer that we will be getting won't be undefined. 6. The limit of a function raised to a power n is equal to the limit of that function as a whole raised to that power n. But in this case, it must be noted that the power n must be a positive integer. 7. The limit of a constant is also equal to that constant, regardless of the value of a. 8. The limit of x is equal to the value of a. 9. The limit of x raised to a positive integer is equal to a raised to that integer. 10. The same goes as the previous theorem. However, when n is an even number, a is automatically assumed to be greater than 0. This is so that we won't get an imaginary number. And as I have discussed earlier, the value of L must be a real number. And lastly, the limit of the nth root of a function is equal to the nth root of the limit of that function. Now that we have reviewed the basic concepts of limits, it's time to solve some problems. So for our first problem, let's start simple. Solve for the limit of 12 times the square root of x minus 3 over x minus 9 as x approaches 4. Okay, so first we can separate the constant 12, put it out of the limit function, then solve for the limit of both the numerator and the denominator, as shown here. Now simply, we substitute 4 in x, so the square root of 4, which is 2 minus 3, that is equal to negative 1, then 4 minus 9 is negative 5. We now have this expression. And simplifying this, we get 12 over 5 or 2.4. And this is our final answer for the first problem. Next, problem number 2. Find the limit of the absolute value of delta x over delta x as delta x approaches 0. Now, as we can see, we cannot directly substitute 0 into the equation because it will turn out indeterminate, or in the form 0 over 0. So what we'll do here is to take the limit from the left and right side, and the answer from these values must converge. Now, starting with the left side, substituting negative 0.01, this is a value very close to 0, we get negative 1. And then from the right side, we substitute 0.01 into the function and then we get 1. So now, as we can see, regardless of how far or how near a value is to 0, the answer will always be negative 1 from the left side and positive 1 from the right side. Also, if we graph this function, the result of the plot will look like this. Hence, in this problem, we can say that the limit does not exist. Next, we'll talk about another important theorem, which is the squeeze theorem. The squeeze theorem includes these two special cases of trigonometric limits. First, the limit of sine of x over x as x approaches 0 is equal to 1, and the limit of 1 minus cosine x over x as x approaches 0 is equal to 0. Now for problem 3, we'll solve a problem that uses the squeeze theorem. Find the limit of sine of pi over 6 plus delta x minus 1/2 over delta x as delta x approaches 0. So note about this trigonometric identity. Sine a plus b is equal to sine a cosine b plus cosine a sine b. The first step in solving this problem is to simplify this sine expression. So we have this sine pi over 6 times cosine delta x plus cosine pi over 6 sine delta x. Sine pi over 6, that is equal to 1/2, and cosine pi over 6 is equal to square root of 3 over 2. Next, we can separate these two terms, this one and this one. So we have this expression, and then next we can factor out 1/2 out of the limit expression, and we'll get this. There. And now, as we notice these two expressions, these are the first and second trigonometric form of the squeeze theorem. So this value, this is equal to 0, and this one is equal to 1. Simplifying, we'll get a final answer of square root of 3 over 2. Just a recap, in this video, we learned about limits, the 11 basic theorems when solving, and the squeeze theorem. If you have any questions on limits or on Calling 1, you can message me directly on my email or message chen.acads Hub on Facebook. I hope you all learned something today. See you in the next video. Bye!